So the integral of secant x dx has one of the strangest derivations in my opinion, so that's what I think I'm going to do today. So basically we're just going to integrate secant of x, right? So the derivation is strange because we actually have to do a strange operation. I'll show you what that is. So we have the integral of secant x. What we're going to do is we're going to multiply, right? We're going to multiply a top and bottom. Well, if you consider secant x as a fraction, like, secant x over 1, right? We're going to multiply top and bottom by secant x plus tan of x. So this might not make much sense, like, at all. And it didn't make much sense for me either. But you're going to see what happens, right? So basically, that's what we do, right? We multiply top and bottom by secant x plus tan of x. And we get a new integral, right? When we distribute the secant x, we get the integral of secant squared x plus secant x tan of x, right? And the denominator is just 1, so doing a multiplication, we end up with just secant x plus tan of x. And can't forget the dx. So you might see now why we multiply the top and bottom by secant x plus tan of x. So if you don't see it, well, I'll go walk through it with you. So let's see here. If we took the bottom, if we took the denominator, right, and differentiated, we'll see what we get. So basically derivative of secant x plus derivative of tan of x, right? So derivative of secant x, that's secant x tan of x, right? And derivative of tan of x, that's just secant squared x. So the derivative of the denominator would just be secant x tan of x plus secant squared x. And notice that's what we have on the top. So this actually sets us up for for a supreme u substitution. If we say u is equal to secant x plus tan of x, we get du, like we said, is equal to secant x tan x plus, oh, I'm running out of space, secant squared x. You should see that, secant squared x. Actually, you know what? I'll fix that right now. Plus secant squared x dx. Oh, I end up in the same situation. Whatever, right? But du secant x tan x plus secant squared x dx, right? You can see that. I just said it. But yeah, anyway. So basically, so we have u, we have du. It's a very good u substitution because we can just divide both sides by well, actually, we don't need to divide both sides. We have a secant squared x plus secant x tan x dx right here. So we can replace that with du, right? Just right there. So we end up with the integral of du over u, right? Which is really just the integral of 1 over u du. And we all know that's a standard integral. It's equal to the natural log of absolute value of u. But u is equal to secant x plus tan of x. So that comes out to a natural log of secant x plus tan of x. Hopefully I don't run out of space. Plus c, right? So yeah, really, it's like a really cool integral because of the clever thing we do by multiplying the top and bottom by secant x plus tan of x. So yeah, once we do that, integral is actually really easy. But yeah, so pretty cool, isn't it? Stay tuned for more cool stuff like this.